or workshop on adversarial information retrieval, and they've had several editions of this workshop over the years. And his name is Brian. His last name skips my mind for a moment, but maybe it'll come to me a little bit later. And he did some of the early work in this area, and Brian Davison is his name, and he introduced this notion called trust rank, and if you look at the expression, it looks very much, it looks very similar to the page rank calculation, and the main difference is that he assumes that that you will be able to identify some set of pages, which he refers to as the seed set, and he assumes that the seed set has certain the number of pages in the seed set is T. T is the seed set, and this cardinality is the number of pages in the seed set. And so if you do some retrieval and you get some page to the some pages that are top ranked, and then from the top ranked pages, if you identify which pages are trusted, then such a list of trusted pages can be used as the seed set. And so just like previously, we tried to find out what is the probability somebody will get to a web page, in the case of page rank calculation. Here we tried to calculate what is the trust associated with page I, and we try to calculate trust associated with page I based on other pages that are linked to this page. And in terms of other pages that are linked to this page, what portion of them or what percentage of them are actually trustworthy? Okay? And also, because of the way it's very similar to page rank, when a particular trusted page points to other pages, it only shares a part of its trust to other pages. And so we similarly have this factor that says how much of this page's trust goes to that page. Okay? And so whenever you do these kind of iterative procedures, you need to start, and you have to initialize trust in some way. And so here the initialization is shown, and the initialization says that each of the pages in the seed set that you can trust, each of them gets a trust score of 1, and all the other pages get no trust value. And then you do the iteration and make the trust score converge. So this basic idea was then, Brian Davison showed how he combines this basic idea with page rank. And page rank, as I told you, is a static computation. And using this approach, he calculates a page rank, which he calls biased page rank or personalized page rank. So it's personalized page rank in the sense that somebody who creates the seed set, they're creating the seed set based on their notion of what is trusted, their notion of what is trustworthy page. So in that sense, combining this score with page rank gives you a way of personalizing the ranking of the results. So this is just saying, what I just mentioned already. This is just making that point. So when you combine the trust score with page rank, we get a score that's called modified page rank. And the modified page rank is again computed by using an iterative scheme. And the iterative scheme is very similar to the structure of it is very similar to what we have seen already. The only important thing to note is that we have this Tj, which is the trust of this J, and the trust of this J was calculated by this earlier slide that I showed you that says, how the seed set can be used to calculate trust. So, this is just a pictorial example, and there are some pages, and the linkages are shown. Again, unfortunately, these arrows are kind of too small. I don't know enough PowerPoint, and I don't know enough how to change the figure and all this. My student did that, and I just left it. I hope you can see. But so, these are trusted pages. These are pages we don't know, and these are spam pages. Like, remember earlier on I told you that people try to increase the incoming links by creating some pages and then making links from those pages to their page. So sometimes they create a bunch of pages, and then which are, pointing to each other, and these kind of pages are referred to as page forms. They're created by spammers, and they're not untrustworthy pages that are created just for increasing their ranking. And so, in this context, one of the problems that search engine operators face is to try and find out where such forms are existing, and try to ignore them when they calculate page rank. So here it shows using the same picture and using a D value of 0.85. It shows how the page ranks are calculated, and in this case there's no trust information being used. This is just like standard page rank calculations, and you find that these spam pages, they can get 1, 2, 3, 4. These spam pages can get quite high rank. But then Brian Davison showed that when they use the trust rank the way we described it a couple of slides earlier, he showed that these guys will not get the modified page rank, the personalized page rank for these guys. In this case, the reason they get all zeros because these have no incoming edges, and if there are no incoming edges, that means none of the seed sets are pointing to them anyway. And if no seed sets are pointing to them, and so in that sense, any page with no incoming edges will not be getting any trust. And then you can see, for example, 6 gets a couple of incoming pages, but only one of them is trusted. But 6 also gets some input from 9 and also gets some input from 7. And so, in fact, 6 gets the highest value in terms of modified page rank, and then all the other pages get some value, whereas except this 10 and 5, since there are no incoming edges, and 1, 2, 3, 4, they all get no modified page rank. And actually, there are two variations of this. I don't know. I think I'm going to. I think I may have one slide in the wrong place. Let me just skip this one. I don't think I talked about the formula associated with this. My student has done some additional work, and I don't want to worry about it for the moment. Then there's also another way of dealing with using a hits approach, how to incorporate trust information into hits. And again, if you've been following me, I want to just how much time do I have to finish? Huh? Another 15 minutes, or okay. So we already talked